Hello. So this is our class project on eating activity recognition, where our goal is to develop a computing system that can distinguish between eating and non-eating activities. So in the system overview, we started with data acquisition, followed by data cleaning and pre-processing. This is followed by data blending, feature extraction, feature selection, model selection. In the model selection, we explored two paradigms: statistical machine learning models and deep learning models. We reported the classification and accuracy thereafter. So this is in this snippet you can see the EMG data. So this is a normal feature vector from the EMG feature set and the IMU data set, where the big number, that 1544, is the timestamp followed by 8 features, while the IMU have the timestamp and followed by 10 features. Now, in the data cleaning and pre-processing, we remove the irregular and invalid data points, and we merge them into the EMG file format using the timestamps. In the data blending portion, we merge multiple EMG and IMU values, IMU data points, to form a merged and combined data. As the EMG and IMU have different data sampling rate, hence we have to blend them to form a functional data set. So for feature extraction, we explored two approaches. The first approach was feature based on simple concatenation of the raw values of EMG and IMU data. Now, the EMG data had 8 dimensions, while the IMU data had 10 dimensions. Therefore, the feature vector that was generated for each instance was 18 dimensions. The next approach had 8 basic statistical features, including count, maximum, minimum, mean, and the standard deviation with 25, 50, and 75 percentile. This is followed by the feature selection module, where we explored 3 methods. The first one is taking all feature values into consideration. The second was L1 based feature selection, and the third one is tree based feature selection. Now, in the model selection part, we actually, as mentioned before, we explored two paradigms. The first was 4 type of classifiers: support vector machines, random forest classifier, XGBoost, and logistic regression. In the deep learning model, we explored LSTMs, especially convolutional LSTMs, where we augmented LSTMs with spatial affinity matrices and attention models. Now, most works focus on single shallow features. The rest ignore the variations in characteristics of features from multiple sensors, which may adversely affect model performance. To mitigate the shortcomings, we propose a methodology that captures a user's real-world behavioral attributes and preserves interfeature correlations along with identifying temporal dependencies between sensor data. Prior research on time series data suggests that along with identifying temporal correlations between different time steps, capturing correlations between pairs of time series is also essential to draw inference from a multivariate time series data. Specifically, to capture the spatial information from n time series, we construct a feature affinity matrix by utilizing pairwise inner product of two different time series within a variable time frame. And this is followed by convolutional LSTMs and self-attention models. After the attention layer, we use further convolutional and fully connected dense layers for the classification. Now, for the evaluation methods, we utilize two matrices. One is the accuracy percentage. We also reported the confusion matrix. The steps undertaken during the training models is partitioning the data into train and test set with 80-20% split. Initially, the data set was unbalanced, and we had to make the data set balanced with same occurrences of eating activity and non-eating activity. To make our model more generalized, we incorporated sensor data from both right and left-handed people. So, moving on to the code. So, this is our data preprocessing code. This is followed by converting that data preprocessing the features into a time series format. Now, this is the code for attention-based conv LSTMs, where the attention between the spatial attention between features is captured in this attention 1 layer. This is followed by building of the affinity matrix. Now, this affinity matrix is merged with a conv LSTM layer followed by a dense layer to predict the values, the Y values. Next comes the attention-based conv LSTM. So this is actually a dense network where we have used multiple conv LSTMs followed by a cross attention between layers, followed by conv layers, conv 1D layers, and dense layers after flattening the conv layers to get the predicted values. Involves those in statistical machine learning where we started with data vectorization followed by feature selection. Now, two feature selections were explored: L1 based feature selection and tree based feature selection. This is followed by classification where we have used support vector machines. Now, in order to search the optimal parameters for the SVM, we used grid search. We have reported the testing accuracy for balanced as well as the unbalanced data. We have plotted the confusion matrix as well. Now, this is followed by, so we have taken similar procedures and we have run our features on different classifiers such as random forest. So with this, we come to the end of the presentation. Thank you.